Bismillahirrahmanirrahim. Here is Dr. Naila Khalid with another lecture based on elevation of boiling point as colligative property. So we will learn about this colligative property that is called elevation of boiling point. As you know, colligative properties are those properties which are dependent on the concentration of the solute. So we have learned in our previous session about lowering of vapor pressure, and now we will discuss the boiling point elevation of the solution. This is also a colligative property. So this topic has been taken from your course. It is also known as ebullioscopy. So we will discuss that how the elevation of boiling point is known as colligative property and what are calculations which are based on these boiling point elevation are you have to learn. Colligative properties are those properties which are dependent on the concentration of solute. So no matter what type of solute is present, what is its identity, what is its chemical nature, it is independent of its chemical nature. It is only dependent on the amount or concentration of the solute. That is why this is called colligative property. So in this session, we will discuss about boiling point elevation. It means that the boiling point of pure solvent is lower than the boiling point of the solution. The boiling point of solution is elevated or higher than the boiling point of the pure solvent. So as you know, the boiling point is the temperature at which the vapor pressure of the liquid becomes equal to the applied pressure or external pressure. In an open container, this applied pressure will be equal to the external pressure, that is atmospheric pressure. That atmospheric pressure may be 1 atm standard unit है. This is also equal to 760 millimeter of mercury and it is equal to 101.3 pascal. ये कन्वर्जन यूनिट्स जो हैं वो आपको याद होने चाहिए. बॉइलिंग पॉइंट वो टेम्परेचर है जिस पे वेपर प्रेशर ऑफ लिक्विड और अप्लाइड प्रेशर या एक्सटर्नल प्रेशर दोनों इक्वल हो जाते हैं और ये एक लिक्विड के लिए खास होता है और इसको हम एक्सप्लेन कर सकते हैं वेपर प्रेशर और टेम्परेचर कर्व से. This can be explained by this one. This is the curve for the diethyl ether. Diethyl ether, when you increase the temperature, the vapor pressure of the liquid is also increasing. And the point comes when the vapor pressure of the liquid becomes equal to the atmospheric pressure. This is atmospheric pressure. When it is equal to atmospheric pressure, at that point, the temperature is called its boiling point because liquid starts boiling over here. In the second example, ethyl alcohol, the vapor pressure of the liquid ethyl alcohol becomes equal to the atmospheric pressure at this temperature. So this is the boiling point of ethyl alcohol. And here is the boiling point of water because this curve is for water. Boiling point of the liquid depends on intermolecular forces. In simple words, I can say that that liquid with higher or stronger intermolecular forces will have lower vapor pressure and high boiling point, and vice versa for those which has weak intermolecular forces. This can be explained by this diagram. In this diagram, you can see the liquid's molecules are arranged in such a way. If there are strong intermolecular forces, there will be less vapors in the here in this space. So there will be less vapor pressure. Lowering of vapor pressure take place, less vapor pressure. Then if the vapor pressure is less, then it will take longer time or higher temperature to get boiled. So that is why the stronger intermolecular forces will lead to the elevation in boiling point, high boiling point. If these intermolecular forces are weak, then these molecules will be more in vapor phase, will have higher vapor pressure and more or less equal to or less, very less than atmospheric pressure. So that is why at very low temperature it can be boiled. So in simple words, I can say that if there is strong intermolecular forces in liquid, then it will lead to higher boiling point, and if these are weak, then it will lead to lower boiling point. Boiling point of liquid also you can say that it is dependent on intermolecular attractive forces. In this example, you can say diethyl ether and N-butanol. Both are of approximately equal molecular weight, but there is difference in their nature. This diethyl ether do not develop hydrogen bonding, whereas N-butanol develop hydrogen bonding. So that is why, due to strong intermolecular forces, its boiling point is higher than the diethyl ether. And ionic forces are too much high as compared to hydrogen bonding. That is why its boiling point is greater than 260 degrees centigrade. This compound is called sodium and butoxide, and this is actually ionic in nature. You can also see this same trend in the melting point. Those molecules which contain ionic bonding which have highest melting point, and those which contain hydrogen bonding has lower melting point than the ionic one, and greater melting point than those which do not have hydrogen bonding. Butanol has no hydrogen bonding, but it has only dipole-dipole interaction. So that is why its melting point is lower than the melting point of the butanol. And same is trend you can see in the alkane or hydrocarbon, where only weak intermolecular forces are there. So that is why their melting point is also lower, and the least in this trend. Now, what is elevation of boiling point? Elevation means higher. The boiling point of the solution is higher than the boiling point of the pure solvent. Why it is higher? Actually, when you add non-volatile solute to the pure solvent, it causes solutions to have higher boiling point. Why it has higher boiling point? Because non-volatile solute decreases its vapor pressure, and hence its boiling point is increased. So this is the solution in which the solute, if it is present over here, it will lower the vapor pressure and increase the boiling point. However, the pure solvent will boil at lower temperature than the solution. Same trend you can present it graphically. This is the molarity or concentration of the sucrose solution in water. Pure water boils at 100 degrees centigrade, but 1 molar solution will boil at higher temperature. And you will see and observe, you will observe the elevation of boiling point of the solution with increase in their concentration. So that is why this elevation in boiling point is also called colligative property. uh, this can be mathematically, this can be written as change in boiling point. Elevation in boiling point is directly proportional to the concentration, whether it is molarity or molality. It is directly proportional to molarity or molarity, so our concentration unit. So it is the proportionality constant, which is also known as ebullioscopic constant. So it can also be explained by this temperature pressure curve, where the solution boiling point is higher as compared to the pure solvent boiling point. From the equation, we can also calculate the concentration of the solute here. And then units of ebullioscopic constant is for 1 molar solution, then it is equal to Kelvin kilogram per mole. So this equation is very useful in calculating the concentration of the solute. So you can see on this screen molality. By putting this molality, the value of molality, then you can calculate this change in temperature. You can calculate the molar mass of the solute. Here is one of the numerical which shows that what is the molecular mass of organic compound. ये एक organic compound है, उसका molecular mass आपने calculate करना है. 16 ग्राम ऑर्गेनिक कंपाउंड को डिसॉल्व किया गया है. 225 ग्राम CCl4 कार्बन टेट्राक्लोराइड एक सॉल्वेंट है जिसके अंदर एक ऑर्गेनिक कंपाउंड को डिसॉल्व किया गया है. इन दोनों अमाउंट से आप मोलैलिटी आसानी से कैलकुलेट कर सकते हैं. और रेजेस इन द बॉइलिंग पॉइंट टू 85.36 डिग्री सेंटीग्रेड। तो इस तरह हम ये कह सकते हैं कि ब्यूलिस्कोपिक कांस्टेंट जो है कार्बन टेट्राक्लोराइड का, वो 5.03 डिग्री सेंटीग्रेड है, जो कि हमने लिटरेचर से मालूम किया है। और CCl4 का बॉइलिंग पॉइंट 76 डिग्री सेंटीग्रेड है। और अगर इन दोनों का जो डिफरेंस है वो आपको डेल्टा टी बी की वैल्यू देता है। तो डेल्टा टी बी की वैल्यू वॉन्ट ऑफ फैक्टर 1 है, ये बिलोस्कोपिक कांस्टेंट है। और इससे आप मोलर मास जो है, मोल पहले नंबर ऑफ मोल्स, ये एक्स नंबर ऑफ मोल्स हैं, और ये सॉल्वेंट का वेट है, ये आप मालूम कर सकते हैं। आपने नंबर ऑफ मोल्स इस तरह कैलकुलेट किए, और उन नंबर ऑफ मोल्स को और वेट ऑफ सॉल्यूट को देखते हुए आपने मोलर मास जो है वो इस तरह कैलकुलेट किया। क्योंकि मोलर मास जो है उसका जो फॉर्मूला है, नंबर ऑफ मोल्स इज इक्वल टू वेट डिवाइड बाय मोलिकुलर वेट से के फॉर्मूला से आपने इसको कैलकुलेट किया। दिस इज द सेकेंड न्यूमेरिकल विच शोज दैट द सिट्रिक एसिड वन ऑफ द सॉल्यूट, इसका ये मॉलिक्यूलर वेट इससे आप मालूम कर सकते हैं, उसको डिसॉल्व किया गया है 50 ग्राम एसिटिक एसिड में। एसिटिक एसिड जो है वो सॉल्वेंट है, सिट्रिक एसिड सॉल्यूट है। और एलिवेशन इन बॉइलिंग पॉइंट जो है वो मालूम देखा गया है 1.76 ऑब्जर्व किया गया है। के भी जो है एसिटिक एसिड का 3.07 है। आपने मोलैलिटी सोल्यूशन की मालूम करनी है, उसके लिए आप ये फॉर्मूला यूज करेंगे, इंस्टेड ऑफ कैपिटल एम स्मॉल एम लिखे मोलैलिटी के लिए। 1.76 ये टेम्परेचर है बॉइलिंग पॉइंट, इसमें जो है यहाँ पे रखा जाता है, ये लिखा गया है। और के भी जो है वो 3.07 है। और मोलैलिटी आप कैलकुलेट कर सकते हैं, दिस इज द मोलैलिटी ऑफ द सिट्रिक एसिड इन एसिटिक एसिड। बॉइलिंग पॉइंट एलिवेशन की आप बहुत सारी एग्जांपल्स जो अपने डेली लाइफ में दे सकते हैं कि अगर आप प्योर वाटर यूज करेंगे वो जल्दी बॉयल करेगा, लेकिन कार रेडिएटर में, और जल्दी उसको हीट अप कर देगा। लेकिन अगर आप उसमें कोई सॉल्यूट ऐड करते हैं जो कि कूलेंट का काम करता है, वो उसके बॉइलिंग पॉइंट को एलिवेट कर देगा, तो वो हायर टेम्परेचर पे जाके बॉयल होगा। तो इस तरह आप कार रेडिएटर्स को ओवर हीटिंग से बचा सकते हैं। इसी तरह कुकिंग के दौरान जब वाटर में साल्ट यूज किया जाता है तो उससे बॉइलिंग पॉइंट एलिवेट हो जाता है और कुकिंग में आसानी होती है। इसी तरह आप इस कॉन्सेप्ट को यूज कर सकते हैं फॉर मॉनिटरिंग सॉल्यूशन सेचुरेशन इन शुगर रिफाइनिंग। शुगर रिफाइनिंग में जो हम कंसंट्रेटेड सॉल्यूशन यूज करते हैं, उसमें भी हम ये कॉन्सेप्ट जो है वो यूज कर सकते हैं, क्योंकि बॉइलिंग पॉइंट उसका भी एलिवेटेड होता है। So in this session, we have discussed that one of the colligative property, that is boiling point elevation, that is special property of solution, के जिसकी वजह से उनका बॉइलिंग पॉइंट जो है वो हायर हो जाता है। और इसी में हमने कैलकुलेशन, स्पेशली मोलर बॉइलिंग पॉइंट जो है, एलिवेशन कांस्टेंट को मालूम करना सीखा है, और उसमें मोलैलिटी को भी का उसके साथ रिलेशनशिप को कैलकुलेट करना सीखा है। सो दिस इज द एंड ऑफ दिस लेक्चर। सो this is the end of this lecture.